Okay, your biostatistics course is started. So today we'll try to see about the data summarization using the measure of variation. Okay, in the last video lecture we had seen about the data summarization using the central tendency or measure of location. So today we'll try to use this, okay, the continuation phase of the data summarization. So the data can be summarized both using the central tendency or based on the measure of location as well as based on the measure of variation, okay, at the same time. So we use one from the central location and one from the measure of variation. So at the data summarization using the measure of variation or measure of dispersion or measure of spreads are arranged the quartiles and the standard deviation, okay, but not limited to this one. So there could be the variance, even though it's not as custom or it's not familiar in the biostatistics, and the percentiles could also, deciles could also be used, but we are only focused on the most important measure of variation which can be applied in the biostatistics. Okay, so as you know, the measure of variation is spread. Okay, so the dispersion or the dispersion of a distribution relieves or reveals how the observations are spread out, okay, varied or scattered on each side of the center. That means from their mean, okay? So from the center means the central location or the measure of central tendency usually they indicates the distribution or the location of the observation, okay, or the data. So the measure of variation, however, they tell us how each observation has been just spread or scattered away from the mean, okay, away from the mean. So to measure the dispersion or the scatter or the variation of the distribution is as important as to locate the central tendency. That means both the measure of central tendency as well as the measure of variation have the same, okay, the same. So they are not of different, okay. So we need to summarize our data in the form of central tendency as well as in the form of variation. For instance, so if you want to summarize your data using mean as a central tendency, at the same time you need to use a standard deviation from the measure of variation. So that means the standard deviation, it tells about how each observation has been just scattered or dispersed from their mean, okay. So if the data distribution is not normal, so in this case we give the median from the central tendency. So from the measure of variation we give the interquartile range, okay, the interquartile range, and the median can be used together. So this is the measure of variation is the degree to which the numerical or quantitative data tend to spread about an average value. So how they have been just scattered or spread out or dispersed, okay, from their mean, from the average values. So if the value of the measure of variation becomes very large, so the data has been just spread out, okay, very large, okay, in high amounts, it has been just varied. Okay? It's not a normal distribution. So in case of, for example, in your case, if the standard deviation of your exam, okay, if this has been just very large or high in number, so that means your knowledge is the same, it's not a normal distribution. So some students may have high knowledge or high score, while the other has scored low, or the knowledge could also be at the same time, it could be low, okay. So it tells about something clue about the ability of students, okay. So some of the most commonly used of measure of dispersion or measure of variation or measure of scatterness are the range, the quartiles, and the standard deviation, okay. So we'll try to focus on this one, but not limited to this one, okay. There are also the range. So range is the simplest measure of dispersion, okay, the simplest measure of dispersion, and it is the difference between the highest and the lowest value of the observation, okay. The highest, it only consider two values, which is the highest value and the lowest value. So if you remember, one of the advantage of range is just to determine the widths, okay, during the formation or construction of group data. So the width is equal to range over the class interval k, the range is the largest value minus the smallest value divided by the k. So range cannot be used during the grouped frequency. Okay, when you construct grouped frequency, so to determine the width, so range can be used. Okay, can be used. But other than that, so range has no such significant value or significant contribution in the biostatics as well in the medical world, because it only considers the two values. Okay, it does not have any concern for the remaining values. Okay, the remaining values. But it gives us some clue, okay, some clue about the lowest and the highest value. So, for example, the diastolic blood pressure of 10 individuals has been just depicted in the follows: 83, 75, 81, 79, 71, 90, 75, 95, okay, here, and 77, 94. So, just to find the range, you need to arrange sequentially. Okay, you need to sort out as in ascending manner. Okay, in ascending manner. So it is impossible, or it is very difficult, just to determine the range simple in the unorganized data. Okay, in unorganized. So the data should be just ordered in the ordered array form. Okay, just to determine the range. So here the range can be expressed as 95 to 70, or 71 up to 95. Okay, 71 to 95 up to 71. Or there is a difference in 24 millimeter mercury. Okay, the diastolic blood pressure of these 10 individuals has a range of 24. Okay, 24. So that means one individual have the highest amount of the diastolic blood pressure. So, if the data set in classes or groups, the range will be between the lowest midpoint of the class or group and the highest midpoint class of the group in case of the grouped data. So, however, the range, as I said before, the range have insignificant contribution for the medical world. So, the most important form of that measure of variation is the quartiles. Okay, quartiles. As you know, the medians. Okay, the medians divides a given data set into two. That means half or 15% of the data is lie below that cutoff point, and the remaining 50 point has been just found above that cutoff point. Okay, above that cutoff point. So quartile means quarter. Okay, that means 4. So here, quartiles, they divide the data set into 4 equal halves. Into 4 equal halves. Okay, 25, 25, 25, and 25. Okay, so therefore logically there should be 3 quartiles for a given distribution. But if you think about it, the second quartile is equal to the median itself. Okay, we will deal with the other 2 quartiles in this section. That means the first quartile and the third quartile. Okay, the third quartile. So that means the second quartile is obviously known. That is what the second quartile means the median. Okay, the median. So we will try to focus mainly about the third and the first one, because we are going to calculate the interquartile range. So our concern is just to find out the interquartile range, the difference between the first and the third quartile of the data. So because it is very important in case if our data is not normally distributed, or if our data is skewed, or it could be negatively distributed, or it could be positively skewed. So in this case we use the median just to summarize the data. So we couldn't use the mean. Okay, in case of skewed data. So mean can be used together with the interquartile range. Okay, so the first quartile, sometimes called the lower quartile, or the 25th percentile. Okay, percentile means in short dividing the data set into 100 equal parts. Okay, 100. Okay, dividing the data set into 100. If you remember, at the beginning of our class, I told you that your score of grade 8 living examination, for example, in grade 8, the data has been just summarized in the form of the average and the percentile. Okay, there is average, so one student may score 80. Okay, 80 average, And the percentile would be just 99.9. It says like that. But most of you told for your parents that you had got a percentile of 99.9. So your score is 99.9. So that's obviously false. Okay, percentile indicates that, for instance, if your average value is 80, and the percentile is 99.9, that means 90.9% of students have scored 80 and below that. Okay, 80 and below that. That is the interpretation. So most probably one student scored above 80. Okay, so this is one of the first quartile or the lower quartile of the 25th percentile, also denoted by Q1. So this corresponded to the value that lies half between the median and the lowest value in the distribution. Okay, so it is found in the between the median and the lowest, which is the 25% of the distribution. Okay, 25% of the distribution can be just found below the Q1. Below the Q1. So this can be just found when the data is sorted in ascending order, since it marks the region which encloses 25% of the initial data. Okay, so median covers the 50%, while the first quartile or the Q1 or the lowest quartile can encloses mainly the 25% of the data. So similarly, the third quartile, okay, the third quartile or the upper quartile or the 57th percentile, also denoted by Q3. So this corresponds to the value that lies halfway between the median and the highest value in the distribution. So mind you, so the first quartile, okay, the first quartile corresponds to the value that lies between the median and the lowest 25%. But the third quartile corresponds to the value that lies halfway between the median and the highest value in the distribution, when it is already sorted in ascending order. Don't forget this one. Okay, don't forget this one. So here there is the first quartile, as you know, as you see from the picture. So here there is the first quartile, the second quartile, third quartile, and then the fourth quartile. So the third quartile incorporates about the 75, okay, 75% of the data. That means starting from this to this, okay, starting from this to this we call it the third quartile, okay, third quartile in total. So that means the total incorporates the 75%. But mainly here it is the second quartile. Okay, here is the second quartile. So the value which found between the second quartile and the highest value, okay, it's found between this. Okay, this is the third quartile, and here there is this second quartile, okay, a value which can be found between the second quartile and the lowest 25% of the data distribution is called the first quartile. Okay, the first quartile. So how can we obtain the quartile from a given data set? So as you remember from the calculation of the median, so the median can be calculated by, so median means the midpoint, so dividing our data observation or the total number sample type divided by 2, n over 2, just to calculate the Q2 or the second quartile. Q2 is equal to n over 2. N means the number of sample size divided. So when we divide the sample size into 2, so we obtain the median. So in case of the first and the third quartile, the calculation is of difference. So n plus 1 divided by 4. That means dividing into 4. That because quartile means dividing the data into 4 equal parts. Okay. So here Q3 is equal to 3/4. Okay, 3/4. That means almost 5%. 3/4. Okay, 3/4 of n plus 1 term. Okay. While the interquartile range means the Q3 minus Q1. So it tells about the distribution, okay, the scatterness of the data from their mid, okay, point, from the midpoint, that is from the median. So here interquartile is the difference between the 25th percentile and the 75th or 75th percentile, and calculated by subtracting the Q3 from the Q1. So this interquartile range is best used as how is the variation or the dispersion or the scatterness between the two quartiles, okay? The 25th percentile and the 75th percentile. So that means ignoring the lower and the upper values, okay? Ignoring the lower and the upper values. So it is can be this interquartile range can be used together with that of the median. So here let's see 11 cholesterol levels has been just put it in millimole per liter, so has been just presented as follows. So that finds the Q1, Q2 and Q3. Here the formula for the Q1 or the 25th percentile is Q1 is equal to n plus 1 divided by 4 this term, okay? The n plus 1 divided by 4 is the term or the distribution which is found n plus 1 divided by 4 is the value of the first quartile. So here let's substitute n means 15, so when we count this, the total set is 15. So here 15 plus 1, okay, 15 plus 1 is 16. 16 divided by 4 is, what is 16 divided by 4? 4. So Q1 is the fourth term. Q1 means that the fourth term. So what is the fourth term? First we need to sort out our data in ascending manner. Already the data has been just sorted out, okay, sorted out. So we'll try to go to the fourth term. So this is the first, second, third, fourth. Here it is. So the fourth observation is our first quartile. Okay, our first quartile. That means 3.7, okay, millimole per liter. 25% of men who have participated in the study have a cholesterol level of 3.7 and below. Okay, mind you, the interpretation is just like this. Okay, 25% of men who has just participated in our study have a cholesterol level of 3.7 millimole per liter. This is the interpretation. So when we come to Q2, that is the median, okay, the 15th percentile is Q is equal to n plus 1 over 2. So, or this is for the odd number, okay, for the odd. If the data is even, so this will be just different. So here 15 plus 1 divided by 2. 16 by 2 is 8. Okay, the 8th term, that means we're going to count 1, 2, 3, 4, 5, 6, 7, 8. The number 8th term is the second quartile or the 15th percentile. Okay, so that means what does 4.5? This means that, you see, this means that men, okay, or man or participants, our participants or our study participants, okay, that means 50% of men who have participated in our study have a cholesterol level of 4.5 and below. Okay, 4.5 and below. So this is our interpretation, the interpretation for the median. Okay, so that meaning, okay, that has a 50%, that means they have a 4.5 above 4.5, okay, above 4.5. So Q3, that means the 17th percentile can be calculated. Q is equal to 3 into n plus 1 by 4. So here 3 into 15 plus 1 is 16. 16 by 3 is 48. 48 divided by 4 is 12. So from this order array distribution, the number 12 observation is the 17th percentile. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here is 12. Okay, this is 12. The 12th observation is 5.7. This means that 75%, okay, 75% of our study participants have a cholesterol level of 5.7 and below. Mind you, 75 Q3 means 75% of our study subjects have a cholesterol level of 5.7 and below. This is interpretation. So what is the interquartile range? IQ R is equal to Q3 minus Q1. So Q3 is 5.7 minus 3.7, which is equal to 2. So what does interquartile? So this means that there is a variation of 2 millimole per liter between the first and the third quartile. Okay, between the first and the third quartile. So when you take the median, so together with the mode, so when you add, okay, when you add here 2, so you may obtain 6.5, and when you subtract this, you can obtain 1, okay, 1 point. Or around 1.7, so that means already 2. Okay, the difference is around 2. So here, this is how the interquartile and the quartile has been just used in the biology, so in the biostatistics. So the most common one is the interquartile. So take it as a self-exercise and the homework exercise. So do it by yourself. Okay, so fortunately the data has been just put in the ascending manner, so you need to just simply just calculate. Okay, so calculate the first, second, third in the interquartile range for the following score. So try and you will become perfect. So the other is the variance. So this variance is usually one form of data measurement of the dispersion. Okay, so this measure of the dispersion is usually relative to the mean. So, however, so this variance has not been just familiar or as custom. Okay, so the variance depends on the average of the squared deviation of observation away from their mean in a set of observation. So that means the squared. That means subtracting mean from each observation. Then when you squared it. So, and then finally sending this squared mean difference, you will obtain the variance. Okay, the variance. So, when the values are closer to their mean or narrow range, so the dispersion is less than when there is scattering over a wide range. So, the value, if the value of the variance is small, so we can say the dispersion is less, or the data has been just less dispersed. If the value of the variance is very high, so we can say that the dispersion is high, or the data has been just highly dispersed. Okay. However, this variance did not used commonly. Okay. We can't use the variance for the measure of summarization. Okay, as the measure of variance summarization. Usually, so this is how to calculate the variance. Okay. So this is the xi means the individual value or observation, minus the mean, then square, then the summation divided by n minus 1. This n minus 1 was called degree of freedom. Okay, the degree of freedom, so that can freely rotate, okay, without any affection. Okay, so a single value can be rotate itself in n minus 1. Okay, n minus 1 observation. So I will show you a good example. Okay, good example. So here. The variance can be just different, but I want to just focus on the standard deviation. Okay, standard deviation is the most common, and it is the measure that is accustomed and widely used in the biostatistics as the measure of variability. Okay, so familiar. Okay, most commonly we use the standard deviation from the measure of variation. So standard deviation can be used together with the mean from the central location, standard deviation for the measure of variability, median from the central location, interquartile range from the measure of variation. Don't forget this one. This is the most important thing. What you need to know. Okay, what you have to know is that the standard deviation can be used together with the mean, and the median can be used together with that of the interquartile range. So the standard deviation is simply it is the square root of the variance. Okay, the variance. So the positive square root of the variance. It can be defined as the average of the deviations of observations, the mean deviation of observation away from their mean in a set of observation. Okay, so if the value of the standard deviation is very high, so it means the large variation of the data hypothesis, and if it is small value, it means that there is less variation of the data hypothesis. Okay, so based on the standard deviation, one can simply predict the type of the data, okay, the type of the data. So how the data has been just distributed. Is it normally distributed or is it not normally distributed? So it is very important, okay. So how can we determine the standard deviation? So for example, calculate the standard deviation of the following data. So 2, 4, 6, 8, 10. So first, to determine the standard deviation, so first we need to determine the mean. Okay, then using the following formula, using this formula, we are going to determine what? The standard deviation. So here, when we determine the mean, so the mean is 6. 6 is the mean. So the next step is individual observation minus the mean. So individual, the first one is 2. 2 minus 6 is negative 4. Okay, isn't it? Negative 4. 4 minus 6, negative 2. 6 minus 6, 0. 8 minus 6, 2. Isn't it? Exactly. Good. And 10 minus 6 is 4. Then finally, we are going to square it. Okay? So minus 4, the whole square is 16. Minus 2, when we squared it, it gives us positive 4. 0 is 0. 2 square means 4. 4 square means 16. Isn't it? Good. So add this one. Okay, the summation. So this is this symbol indicates the summation. Okay, we need to submit. So when we submit it, or when we add this number, we obtain what? 40. Say 40 divided by n minus 1, the degree of freedom. Okay, here the sample size is 1, 2, 3, 4, 5. 5 means what? 5 minus 1 is 4. So 40 divided by 4 is 10. So the square root of 10. Okay, the square root of 10 is the sample standard deviation. That means nearly what? This is nearly 3 point something like, okay? This is nearly 3 point, okay? 3.2 or something like that, okay? 3.2 something like that. So this is the standard deviation, okay? The standard. So that means what? So this standard deviation indicates how the variations, okay? How the individual numbers or individual observation varied varied from what? From their mean, okay? So from their mean. So on average, each individual observation is varied on 3.2. Okay, on 3.2. So some scores when you add 6.3.2, so 9.2. So there is a value which is what? 9.2, and when you subtract here from 6, 3, 2.8. Okay, there is a value which is what? Less than the mean, which is 2.8. Okay, so usually the standard deviation can be used together with the mean. Okay, together with the mean. So the other is the standard deviation calculation for the grouped data. So if the data is grouped, so we need to know how to calculate the standard deviation. So here it is the simple steps. Okay, so this is the simple steps of calculating the standard deviation. So first, find the mean of the grouped data. You know how to calculate mean for the grouped data, isn't it? So we'll try to see the house. So take the midpoint, okay, each of class, and subtract mean from each observations. Okay, that means from the midpoint, okay, from the midpoint subtract the mean. Okay, from the mean we try to subtract the mean. Then number 3, square each value from step 2. That means midpoint minus, okay, midpoint minus mean the whole square. So number 4, multiply each number from step 3 by each class interval frequency. So in the group frequency, we'll have what? We'll have the frequencies, isn't it? The class frequency. So then finally this the squared, okay, the number 3 squared value can be just multiplied by the frequency. Then finally add all the steps in the step 4. Then divide this total number by the n minus 1, or by the degree of freedom. Then finally just make or insert into square root, or make a square root to this number. Okay, so this is an example. Okay, an example. So find the standard deviation of 30 second year public health students spend on their first online biostatistics quiz. Okay, so the first one is 1 to 5 minutes. Within 1 to 5 minutes, 3 students completed the quiz, and from 6 to 10 minutes, 10 students completed. From 11 to 15 minutes, 8 students completed the exam. From 16 to 20 minutes, and 6 students completed. A total of 30 students completed. Okay, from from a single section. So we need to calculate the true class limit. Okay, so this is the true class limit. So just to obtain the true class limit, subtract 0.5 from the lower limit and add 0.5 for the upper limit. Okay, so here the midpoint. Then finally find, okay, the midpoint from the two classes, 0.5 plus 5.5 divided by 2. It is 6 divided by 2 is 3. The same thing, okay, the same thing, we'll try to count this one. Then finally, just multiply the midpoint by the frequency. Okay, here it is. So finally, we'll try to calculate on the mean. Mean is equal to the summation of midpoint times the frequency, the class frequency, divided by what? The summation of the frequency, that is the 30. Okay, so that means 300 divided by 30 is 10. So the mean is 30. The mean is 10. So the standard deviation can be just calculated by the summation of frequency times the class frequency. Okay, the square root of the summation of the class frequency times the midpoint minus the mean, the whole square. So, for instance, this class interval, okay, has the mean square deviation. Okay, so this is the midpoint. The midpoint is 3 minus 10. 3 minus 10. Okay, 3 minus 10 is 7. Minus 7. Minus 7 square is 49. Here, when you come to here, the midpoint is 8. 8 minus 10. 10 is the mean. 2. 2 square, 4. Here, when you come to here, 13 minus 10 is 3. 3 square is 9. Here, the midpoint is 18. 18 minus 10 is 8. 8 square is 64. Then finally, multiply this by the frequency, okay, the class frequency. So, when we multiply the class frequency, we can obtain that. Okay, we can obtain that this usually this is not 6. This is what? This is 3. Okay, this is the class interval is here. It is 3, the frequency. So you can multiply that. Okay, this is 3 times 49 is not 441. So there is a problem here. So then finally you can obtain it. Okay, you can obtain this one. Okay, so then finally 937. So divided by n minus 1. Okay, divided by n minus 1. N means 30 minus 1 is 29. Then finally you can obtain this one. Okay, so you can obtain this one. So this is all about the measure of variability. So if you have any questions, suggestion, or comments, you're welcome anytime. Okay, just please attach me your comments through the either through the college Telegram page or through my individual Telegram page. Okay, thank you very much.